In this question, electron traveling in uniform electric field passes from region of a potential V1 to a region of higher potential V2. So when electron is passing through a region of potential V1 to a region of higher potential V2, that means V2 is greater than V1, it is said. So change in potential energy of the electron, if you write, then change in potential energy of electron will be E times, that is negative charge, V2 minus V1. Okay. V2 minus V1. So V2 minus V1 is positive, so this is minus times E V2 minus V1. So you can see that V2 minus V1 is positive and the electron charge is negative, so its energy has decreased. So no change takes place in the velocity component parallel to the interface of two regions. Okay, so now look here, try to understand. Suppose this is our V1, this is our V2. Okay, so it is saying that electron traveling in uniform electric field. So we have a uniform electric field, and in the direction of electric field potential decreases. Okay, so electric field is basically in this direction. So electron is moving, and it goes from potential field V1 to V1 region to higher potential V2. Okay, so electron is going from here to here. Okay, so it is moving in the direction of opposite to the direction of electric field. Okay, delta U is decreased here, you can clearly see that means kinetic energy will increase. It is saying no change takes place in a velocity component parallel to the interface of two regions. Now the force that electron will experience, the electron at any moment will experience force in this direction. Okay, this is the force experienced by the electron because it is negative charge, so it will experience force in opposite to the electric field. Now this force has no component in the in a direction perpendicular to this electric field, means along the interface of the plane there is no component of this electrostatic force. That means no change takes place in the velocity component parallel to interface of the two regions. So that is right, no problem. Direction of motion remains unchanged but speed increases. No, if the electron is moving like in such a manner that it is perpendicular, it is neither perpendicular to electric field nor parallel to electric field. Let's say at some angle electron is moving like this way. In this sense, you will say that its velocity along this line will increase. Okay, because potential is decreasing, potential energy is decreasing, so kinetic energy will increase, and velocity along this line will remain same. So you will find that with the time this velocity will keep on increasing. Okay, so its direction of motion will change, and now it will go on a parabolic path. Okay, so direction of its motion remain change but speed increases, so that is wrong here. Direction of its motion may change but speed must be decreased. No, speed should be increased because it is moving in the direction opposite to the electric field. No? So speed has to increase because potential energy is decreasing. Decrease in kinetic energy proportional to this one. No, kinetic energy will increase. Okay, because we have decrease in potential energy, and decrease in potential should be equals to increase in kinetic energy, because from conservation of energy delta Q plus delta U should be equals to 0. So delta K will be minus times delta U, and that is what? That is E times V2 minus of V1. Okay, so kinetic energy is increasing and it is proportional to V2 minus V1, not root of V2 minus V1. So correct option should be option A.